Hi, welcome to another episode of Cold Fusion. 2021 was a challenging year for a lot of people, from the tail end of the pandemic to the Taliban and natural disasters. A year of constantly negative headlines could make one feel down. But in late 2021, there was one positive headline among a sea of negativity, a technological achievement that would provide inspiration to humanity. We could look out into the stars and marvel at the universe with clarity never seen before. On Christmas Day 2021, the James Webb Telescope was launched, and on that day, that inspiration was delivered. The James Webb Space Telescope was designed and developed by NASA engineers, along with the European and Canadian space agencies. It is the largest optical telescope ever sent to space. Weighing around 6 tons and costing $10 billion, it's an achievement that was 2 decades in the making. But in just one short year since its launch, the James Webb Telescope has given scientists new perspectives, amazed the public with awe-inspiring imagery, and opened our eyes to the endless possibilities of our universe. In this episode, we'll take a look at 8 amazing discoveries that the James Webb Telescope has gifted us in the year since its launch. But first, we'll dive into a few fun facts.
You are watching Cold Fusion TV.
The imaging system on the James Webb Telescope is so good that it could clearly see a coin from 24 miles or 38 kilometers away, or a football from 340 miles or 547 kilometers away. During its orbit, the side facing away from the Sun gets colder than Antarctica, while the other side can reach temperatures of 185 degrees Fahrenheit or 85 degrees Celsius. Because light has a finite speed and takes time to travel, the further away something is, the more ancient it is. Using infrared light, the James Webb Telescope can look further back in time than ever previously possible. It also allows for scientists to see through dust clouds and see the stars forming inside. Pretty remarkable stuff. Its 18 giant mirrors are made of beryllium, but coated in gold. The coating of gold is only around 600 atoms thick, and the total volume of gold would be the size of a golf ball and weigh 48 grams. So why use gold? Well, this precious metal reflects red light better than pretty much every other metal. 98% reflective versus 85% for a standard mirror. The orbit of the James Webb Telescope is 1 million miles away, or 1.6 million kilometers away, while the Hubble telescope only orbited at 340 miles away. This means that if anything goes wrong, the James Webb Telescope is too far away to service, so after it runs out of fuel, that might be it. But not all hope is lost though. There is a built-in refueling port, so when the fuel runs out, and if humans figure out how to get spacecraft out there routinely, the telescope's life could be extended. In May of 2022, a micrometeorite hit one of the 18 gold mirrors, permanently damaging it. But experts say the effect on the telescope's performance will be minimal. These kinds of impacts were expected, but the damage was far larger than anticipated, and also, this type of collision was only expected once every few years. In November of 2022, the James Webb Telescope captured a phenomenal image of the birth of a new star. At the relatively young age of just 100,000 years, this star is still in the protostar phase of its life. That means that it's still gathering mass from surrounding molecular clouds, a process that can take more than 5,000 years for a low-mass star. Although the protostar is hidden from view, a protoplanetary disk can be seen. It takes the form of a dark line in the center of an hourglass display. The rotating disk is made of dense gas, and the incredible infrared light show is caused by the light from the protostar leaking above and below the disk, illuminating cavities within the gas and the dust surrounding it. What's fascinating about this discovery is that the protoplanetary disk is roughly the size of our solar system, and it's not unusual for planets to form in these conditions. NASA believes that this image provides a glimpse into what could have been seen during the birth of our solar system and sun. Spread across space between 40 and 290 million light-years from Earth sits a collection of galaxies known as Stephan's Quintet. This is part of the Pegasus constellation. Although Stephan's Quintet was first discovered in 1877 by French astronomer Edouard Stephan, the new images captured by the James Webb Telescope have shined a new light on what this constellation of galaxies can teach us. specifically uncovering the secrets of black holes. Although the image of galaxies dancing with one another is spectacular, What can't be seen is of most interest to scientists. Tucked away within the topmost galaxy hides a supermassive black hole, and supermassive is a fitting name. This black hole has a mass a whopping 24 million times that of our Sun, and outputs light energy equivalent to 40 billion suns. Thanks to the advanced techniques available with this new telescope, teams have been able to examine the hot gases near the black hole and measure the velocity of its outflows in astonishing detail. This helps scientists better understand the speed at which supermassive black holes feed and grow. In August of 2022, NASA revealed an exciting discovery. The James Webb Telescope captured the first evidence of carbon dioxide in an atmosphere outside our solar system, and that was just the beginning. Orbiting a Sun-like star 700 light-years from Earth resides a hot gas giant planet roughly the mass of Saturn and the size of Jupiter. Its name is WASP-39b. First discovered in 2011, WASP-39b orbits close to its Sun, making it extremely hot, with an average temperature of 900 degrees Celsius. A team at Johns Hopkins University has confirmed the presence of carbon dioxide in WASP-39b's atmosphere, something no observatory has accomplished before. But WASP-39b had more to offer. In November 2022, new readings from the James Webb Telescope provided an even more extensive list of what makes up the exoplanet's atmosphere, including atoms, molecules, active chemistry, and clouds. This type of data will go a long way to help scientists unlock the bigger picture of what makes up an exoplanet's atmosphere and would open the door to a whole new phase of exoplanet exploration. By the way, an exoplanet is just a planet that's outside our solar system, the first of which was only observed in 1992. Another well-documented view being given new life thanks to the James Webb Telescope is this updated image of the famous Pillars of Creation. These colossal structures made of interstellar gas and dust are part of the Eagle Nebula and sit roughly 7,000 light-years from Earth. The Hubble Space Telescope first captured the pillars in 1995 and again in 2014. While it was groundbreaking at the time, the James Webb Telescope's capabilities have blown that image away. There's much more detail than ever imagined, and it's now on display. New stars are seen forming in the clouds. The heightened transparency of the gas and dust create a three-dimensional understanding of the structure, and the background is now full of light. Lava-like lines can be seen, like molten rock pouring through the cracks in a rock formation. They are ejections from stars in their infancy. They're supersonic jets that create bright, red patterns when colliding with a cloud of material. It's an incredible image that further builds on the groundwork from Hubble. But it also clearly shows how far technology has come. Just a few short days after the James Webb Telescope began sending images back to Earth, the information astronomers gathered was immense. Within just 4 days, researchers found 2 new galaxies. But it wasn't just the discovery that was a surprise. It was the record-breaking distance, because one of these galaxies was confirmed to be the most distant starlight ever observed, dating back a calculated 350 million years after the beginning of the universe. For context, our observable universe is said to be 13 billion years old. Marco Castellano of the National Institute for Astrophysics in Rome said a discovery such as this opens a whole new chapter in astronomy, and compared it to an archaeologist uncovering a lost city. Scientists are now left with one burning question: how was it possible to observe such distant galaxies? This discovery brings us to our next entry. The team that discovered the distant galaxies were from the University of Colorado, and they weren't surprised just at the discovery, but they were perplexed at how they even managed to do it. It made them question their understanding of how galaxies formed in the early stages of the universe. The distant young galaxies captured by the James Webb Telescope are vastly different to the Milky Way and are significantly brighter than astronomers expected them to be. There are 2 theories of how these galaxies emit so much light. The first theory is that they could be simply enormous. But the second theory is far more interesting. It suggests that these galaxies could be centered around the first stars. These early stars, known as Population 3 stars, burned at unimaginable temperatures, made up of only primordial hydrogen and helium. No Population 3 stars exist in the local universe, so we'll have to keep an eye on this and wait to discover the truth behind this mystery. one of the eeriest images captured by the James Webb Telescope was released by astronomers in October of 2022. It was labelled the Cosmic Fingerprint. While the images are ethereal and subtle, what causes the rings is fascinating. The image shows at least 17 concentric rings made of cosmic dust emitting from 2 stars at the centre. This star duo is 5,000 light-years away from Earth. Every 8 years, the stars' orbits bring them close enough to each other so their stellar winds can meet. When this happens, streams of gas are compressed, forming dust, which is sent off into space, creating the pattern we see today. This fingerprint has been likened to the rings of a tree, showing its age. For each ring, an orbital cycle has been completed, and we are gifted with a spectacular show. The power of the James Webb Telescope is on full display here, as previous images of this event showed just 2 rings, and now more than 17 can be observed. "385 light-years away from Earth, with a mass 6 to 12 times heavier than Jupiter, sits HIP 65426, an exoplanet that the James Webb Telescope recently captured. It's the very first exoplanet outside of our solar system that the telescope has taken a direct image of. Capturing direct images of exoplanets is extremely challenging, mainly because the stars that they're right next to are so much brighter. This means only James Webb's near-infrared capabilities can cut through this light to reveal the faint planets in such detail. So why is this exciting? It's because images like this are a massive step forward for scientists. We could potentially see habitable and life-sustaining planets outside of our solar system. Unfortunately, HIP 65426 is a gas giant, meaning of course that it's not habitable. But this image hints at many future possibilities for studying distant worlds. As more exoplanets are observed, it's going to shape researchers' understanding of exoplanet physics, chemistry, and formation. The James Webb Telescope has offered insight into our existence and the future of astronomical research just a year after its launch. According to researchers, all of this barely scratches the surface of what it's capable of. Although the James Webb Telescope has a minimum mission duration of 5 years, it's expected to operate far beyond that, so it's safe to expect that astronomers worldwide will continue to analyze data for many years to come. Just what will be discovered within that data is to be determined, but it could completely change our understanding of the universe. And I'd say that the time that we're living in now is a privilege for anyone with a curious mind. So that just about wraps it up for this episode, and also for this year. There's been plenty of interesting stuff covered on this channel throughout the year, and I want to thank all of you for supporting me and making this all possible. Just some quick housekeeping, there'll be some interesting topics coming up early next year, including the whole story of the Twitter saga with Elon Musk, Sam Bankman-Fried finally getting arrested, a landmark achievement in the field of energy production, and much more. But for now, thanks for watching. My name is Dagogo, and you've been watching Cold Fusion, and I'll send you off with a new track that I recently made. Cheers guys, have a good one.